Hey Algebra 2 students, today's lesson is about completing the square. For today's lesson, you're going to need your Chapter 6 packet, your pencil, and you're definitely going to need your brain for this one. Completing the square is used to convert the equation of a parabola from standard form to vertex form. Vertex form is much easier to graph the parabola on the coordinate plane, so that's why completing the square is so useful. So, here goes nothing. Done. I wish it were that easy. Go ahead and turn to lesson 6.5b in your packet. You'll notice that in problem 1, I've got the first two parts of the equation of a parabola, but I'm missing the last. Right now, I've got ax squared plus bx, but I'm missing the c. To find it, there's a simple algorithm. I'll use b divided by 2 and square it to give me my c value. Once I've got my c value, I can go ahead and plug it in to complete standard form. And once I have my parabola in standard form, I can turn it into the product of two binomials, or one binomial squared. To do this, I will do b over 2, and it'll be x plus b over 2 squared. Now, let's see this in action. Let's look at part A of problem number 1. I'm looking for the missing c value, so I'll do 8 divided by 2, which is 4, square it, and get 16. To rewrite this as a binomial squared, I'll do x plus my b value divided by 2, which is 4, squared. Let's take a look at that again. For part B, I'm missing my c value, so I will divide my b value by 2, which is negative 10, and square it, which is 100. To rewrite this as a binomial squared, it is x minus 10 squared. And I get 10 from dividing that b value by 2. One last time, and with a fraction this time, I'm going to take my b value and divide it by 2, which in this case would be 1/3, and then I'll square it, which gives me 1/9. To rewrite this as a binomial squared, it'll be x minus 1/3 squared. Not too bad, right? Go ahead and move down to problem 2. In these problems, we'll actually use the completing the square method to convert from standard form to vertex form. The first thing I'll need to do is move the constant to the other side of the equation. So in this case, I'm going to subtract 40 from both sides. I'll rewrite the equation like this. Y minus 40 equals x squared plus 12x plus blank. And that's where I need to use my method for completing the square. Up top, we saw that I take the b value, divide it by 2, and square it. So in this case, I'll do 12 divided by 2, which is 6 squared, which is 36. Now, I can't just go adding 36 to one side and not the other, so I'm going to need to add 36 to this side as well. I'll rewrite my equation like so. Y minus 4 equals, and then to write this side as the square of a binomial, it will be x plus 6 squared. Now I have totally rewritten my parabola in vertex form. Let's do one more example. In question number 3, I need to first move the 10 to the other side. I'll rewrite the equation as y minus 10 equals x squared minus 10x plus blank. Here's where I complete the square. I will divide b by 2 and get negative 5. I square it and get 25. I can't add 25 to just one side, so I have to add it to the other side as well. I rewrite my equation as y plus 15 equals, and now I'll rewrite this as the square of a binomial, x plus 5 squared. All good? Not quite. I messed up my sign here, which is a common mistake. I need to realize that b divided by 2 in this case is negative 5. Now I have rewritten my parabola in vertex form. Now you try. Complete problems 4 and 5 and then check your answer. When you're finished, you should have found that for problem 4, I rewrite the standard form as y plus 24 equals the quantity x minus 3 squared. Problem 5 was tricky because there was a decimal, but the process stays the same. The final answer is y minus 4.75 equals the quantity x plus 1.5 squared. If you've successfully completed 4 and 5, I think you're ready to go. Come to class prepared to do the rest of this worksheet together as the problems get a little bit more difficult. There you go. That's how to complete the square and convert from standard form to vertex form.